Now the third chapter of trigonometry is multiple and submultiple angles. Now, if A is an angle, then 2A, 3A, 4A and so on are called multiple angles of A, are called multiple angles of A. They are called multiple angles of A. Okay. And A by 2, A by 3, A by 4, 4A by 5, 5A by 6 and so on are called submultiple angles of A, are called submultiple angles of A. So what we have to do is we have to find trigonometric ratios of angle 2A in terms of angle A. Similarly, we'll find the trigonometric ratios of angle 3A in terms of angle A, and then based on that we'll express trigonometric ratios of angles A in terms of 2A and so on. So let us write the first result of this chapter. Now the first result of this chapter, result 1. To find the trigonometric ratios, to find the trigonometric ratios of an angle 2A. Of an angle 2A in terms of those of the angle A. This is what we have to do now. To find trigonometric ratios of angle 2A in terms of those of angle A. So first one is in this, sine 2A is always equal to 2 sine A cos A. Sine 2A is always equal to 2 sine A cos A for every angle A which is belonging to set of real numbers. Now the second result is cos 2A is always equal to cos square A minus sine square A. Okay, this is equal to 2 cos square A minus 1. This is equal to 1 minus 2 sine square A. Now the third result here is tan 2A is equal to 2 tan A by 1 minus tan square A. 2 tan A by 1 minus tan square A, provided A and 2A are not odd multiples of 90. Otherwise, it becomes undefined, because if A and 2A, they are odd multiples of pi by 2 or 90 degrees, tan A and tan 2A becomes undefined. So what we'll do first is, let us try to write small proof of these results. Y sin 2A is equal to 2 sin A cos A. First, let us prove this result. Sin 2A is equal to 2 sin A cos A. Now remember, sin 2A, we can always write it as sin of A plus A. Sin 2A, we can write it as what? Sin of A plus A. Now remember, in the previous chapter, second chapter of trigonometry, compound angles, in earlier discussion, we had written sin of A plus B formula, if you remember. So using that formula, we can write sin A into cos A plus cos A into sin A. Sin of A plus B formula. So sin A cos A plus cos A sin A, it is nothing but 2 sin A cos A. Therefore, sin 2A formula we try to remember as 2 sin A cos A. This is the proof of y sin 2A is 2 sin A cos A. Now next, we'll try to prove y cos 2A is equal to cos square A minus sin square A. Cos 2A, again we can write it as cos of A plus A. Cos 2A is what? Cos of A plus A. Again, using compound angles chapter formula, cos A plus B, it is cos A into cos A minus sin A into sin A. Because what is cos A plus B? Cos A cos B minus sin A sin B. That is cos A plus B formula in compound angles. Cos A plus B formula is what? Cos A cos B minus sin A sin B in compound angles chapter. Okay. So therefore we get this as cos A into cos A is cos square A, sin A into sin A is sin square. Therefore cos 2A is equal to cos square A minus sin square. But remember, in the first chapter of trigonometric ratios which we have discussed, we told cos square A plus sin square A is always equal to 1. So using this, we can write cos square A as 1 minus sin square A. Therefore we get 1 minus 2 sin square A. This is second formula of cos 2A. This is second formula of cos 2A. Also, cos 2A, which we have proved, cos square A minus sin square A, if you replace sin square A with 1 minus cos square A using this formula, we get minus into minus plus, it becomes 2 cos square A minus 1. This is the third formula of cos 2. So there are three formulas for cos 2A. One is cos square A minus sin square A, other one is 1 minus 2 sin square A, and third formula of cos 2A is 2 cos square A minus 1. So depending upon the problem, we can use these three. Now the third result, that is tan 2a, let us try to prove it is 2 tan a by 1 minus tan square. Okay. So tan 2a, we can write it as tan of a plus a. So again in your compound angles chapter, tan of a plus b formula, already we wrote it as tan a plus tan b by 1 minus tan a tan b. I hope compound angles chapter you have revised. So therefore it is tan a plus tan a by 1 minus tan a into tan a. Therefore numerator tan a plus tan a becomes 2 tan a, denominator becomes 1 minus tan a into tan a means tan square. So this is the third basic formula in multiple submultiple chapter. Tan 2a is equal to 2 tan a by 1 minus tan square a. This is the third basic formula of multiple submultiple chapter. Now one very important note point, let us try to write here. Now since sin 2a is equal to 2 sin a cos a, since sin 2a is equal to 2 sin a cos a, so if you replace angle 2a with a, replacing angle 2a with a, therefore a is replaced with what? A by 2. Replace 2a with a and a with a by 2, we get sin a is equal to 2 sin a by 2 cos a by 2. Sin a is equal to 2 sin a by 2 cos a by 2. If a is replaced with a by 2, if a is replaced with a by 2, then we get sin a by 2 is equal to 2 sin a by 4 cos a by 4. So this becomes trigonometric ratios of submultiple angle. So from sin to a, we can write 2 sin a cos a. From sin to a equal to 2 sin a cos a, we can prove sin a as 2 sin a by 2 cos a by 2. Sin a by 2 equal to 2 sin a by 4 cos a by 4. Similarly, sin a by 4, we can prove 2 sin a by 8 cos a by 8 and so on. So from here we can get trigonometric ratios of submultiple angles also. Similarly, since we have proved cos 2a equal to cos square a minus sin square a, if we replace a with a, that is a with a by 2, we get cos a is equal to cos square A by 2 minus sin square A by 2. Okay. Similarly, if A is replaced with A by 2, we get cos A by 2 equal to cos square A by 4 minus sin square A by 4. So like this we can get trigonometric ratios of submultiple angles also. Similarly, we can write tan A equal to 2 tan A by 2 by 1 minus tan square A by 2, and tan A by 2 equal to 2 tan A by 4 by 1 minus tan square A by 4. This is very important note point which is there in this chapter. Now after that, let us write second result. To express sin to A, cos to A, tan to A in terms of tan A, in terms of tan A. To express sin to A, cos to A, tan to A in terms of tan A. Okay. So first result, sin to A is equal to 2 tan A by 1 plus tan square A. If A is not odd multiple of pi by 2, because otherwise tan will be undefined. Cos 2A is equal to 1 minus tan square A by 1 plus tan square A. And third result is tan 2A is equal to 2 tan A by 1 minus tan square. Sin 2A, cos 2A, tan 2A, writing in terms of tan A. Now the small proof of each is we can prove sin 2A is equal to 2 tan A by 1 plus tan square A using sin 2A formula. Now we have proved just now sin 2A is equal to 2 sin A cos A. Now this we can write it as 2 sin A by cos A into cos square A, because one cos, if it gets cancelled, we get 2 sin A cos A. So therefore this we can write it as sin A by cos A is 2 tan A into cos square A, we can write it as 1 by secant square A. Therefore this is 2 tan A by secant square A. Formula in terms of tan A, we already know that it is 1 plus tan square. Therefore we can write sin 2A completely in terms of tan A also in this manner. Very, very important formula for solving the problems. Now, second one is cos 2a. We have to prove 1 minus tan square a by 1 plus tan square a. Now, we have already proved cos 2a equal to cos square a minus sin square a. Now we can write this cos square a minus sin square a. Take cos square a common. This is 1 minus sin square a by cos square a. If you take cos square a common. Okay. This is cos square a into sin square a by cos square a is tan square a. This is 1 minus tan square a by cos square a is 1 by secant square a. Okay. So therefore, it becomes 1 minus tan square a by 1 plus tan square a. Because secant square a is always 1 plus tan square. So therefore, third result is cos 2a equal to 1 minus tan square a by 1 plus tan square. Similarly, tan 2a already we have proved it is 2 tan a by 1 minus tan square. So, this is the way we can write sin 2a, cos 2a, tan 2a in terms of tan a. This is second result. Now in this chapter, the third result is to find trigonometric ratios of 3a of angle 3a in terms of those of A. This is our third result in this chapter. Trigonometric ratios of 3a in terms of those of A. Okay. So, in this the first result is sin 3a is equal to 3 sin a minus 4 sin cube a. 3 sin a minus 4 sin cube a. This is true for all angle A belonging to set of real numbers. This is the first result of writing sin 3a in terms of A. Second result is cos 3a is always equal to 4 cos cube A minus 3 cos A. Cos 3a is equal to 4 cos cube A minus 3 cos A. And the third result is tan 3a is equal to 3 tan A minus tan cube A, 3 tan A minus tan cube A by 1 minus 3 tan square. This is called finding trigonometric ratios of angle 3A in terms of A. Now for each of them, we are having a small proof before we start remembering. Sin 3a, we can write it as sine of a plus 2a. 3a we can write it as a plus 2a. So sine 3a is sine of a plus 2a. This is sin A cos 2A plus cos A sin 2A. It is sine of A plus B formula. Okay. Now what is cos 2A formula in terms of sin A? Cos 2A formula in terms of sin A is 1 minus 2 sin square A. And sin 2A formula is 2 sin A cos A. Okay. Open the bracket, we get sin A minus 2 sin cube A plus 2 sin A into cos square A. Open the brackets. It is sin A minus 2 sin cube A plus 2 sin A. Cos square A is 1 minus sin square A. Okay. So therefore, it is sin A minus 2 sin cube A plus 2 sin A minus 2 sin cube A. So 2 sin A plus sin A is 3 sin A. 2 sin cube A minus 2 sin cube A is 4 sin. Therefore, sin 3A is equal to 3 sin A minus 4 sin. This is the first result, writing sin 3A completely in terms of A. Similarly, cos 3A formula we can write in terms of A by writing 3A angle as A plus 2A. So again, using cos A plus B formula, we get cos A cos 2A cos A cos 2A minus sin A sin 2A. Okay. Cos A cos 2A minus sin A sin 2A. Now what is cos 2A in terms of cos? It is 2 cos square A minus 1. Just now we have proved. And what is sin 2A formula? 2 sin A cos A. So therefore, open the bracket, we get 2 cos cube A minus cos A minus 2 sin square A into cos A. Okay. This is 2 cos cube A minus cos A. Sin square A, let us write it as 1 minus cos square A. Therefore, it is 2 cos cube A minus cos A minus, open the bracket, we get 2 cos A plus 2 cos cube. Therefore, 2 cos cube A plus 2 cos cube A, 4 cos cube A minus 3 cos. Therefore, we get cos 3A formula as 4 cos cube A minus 3 cos. Similarly, using tan A plus B formula, we can prove tan 3A equal to 3 tan A minus 4 tan cube A, 3 tan A minus tan cube A, 3 tan A minus tan cube A. Okay, 3 tan A minus tan cube A by 1 minus 3 tan square. Using tan A plus B formula, we can also prove tan 3A formula. Now after that, let us write result 4 of this chapter. Result 4. Now result 4 is to express trigonometric ratios of angle A in terms of cos 2A. Let us try to express trigonometric ratios in terms of angle A in terms of cos 2A. This is also very, very useful in many objective questions later on. Now the first result in this is sin A is equal to plus or minus under root of 1 minus cos 2A by 2 for all angle A belonging to R. First result. Sin A is equal to what? Plus or minus under root of 1 minus cos 2A by 2. Cos A is equal to plus or minus under root of 1 plus cos 2A by 2. Okay. And tan A is equal to plus or minus under root of 1 minus cos 2A by 1 plus cos 2. So these are three very, very important results provided here in this case. A belongs to R except it should not become, A should not take odd multiples of 90. Because if A is 90 degrees or odd multiple, tan A is undefined. A can take all real numbers except odd multiples of 90. Now we are having a small proof of all these three results. So the first result, we'll try to prove it as sin A is equal to plus or minus root of 1 minus cos 2A. Similarly, we can prove cos A is equal to plus or minus root of 1 plus cos 2A, and tan A is equal to plus or minus root of 1 minus cos 2A by 1 plus cos 2A. So the first result, let us try to prove here. Now very simple explanation is, now already we know cos 2A is equal to 1 minus 2 sin square A. Okay. So from here 2 sin square A will be equal to 1 minus cos 2A. 2 sin square A is equal to 1 minus cos 2. So therefore sin square A will be equal to 1 minus cos 2A by 2. Therefore sin A is equal to plus or minus root of 1 minus cos 2A divided by 2. This is the first result. Very useful in many questions of this chapter. Now the second result is cos 2A is equal to it is 2 cos square A minus 1. Cos 2A is what? 2 cos square A minus 1. So from here 2 cos square A will be equal to 1 plus cos 2A. So therefore, what is cos square A? Cos square A will be equal to 1 plus cos 2A by 2. So therefore, cos A is equal to plus or minus root of 1 plus cos 2a by 2. This is your second result. Now third result is tan A. We all know it is sin A by cos A. So therefore, taking cos A as equation 2 and sin A as equation 1, we get dividing 1 by 2, we get plus or minus root of 1 minus cos 2a by 1 plus cos 2. This is your third result. What is the third result? Tan A is equal to plus or minus root of 1 minus cos 2a by 1 plus cos 2. Like this, we are having 4 to 5 results more, and once we write those 4-5 results, we can discuss some very important questions of this chapter. Those questions we'll discuss in our next